Time for a little more logarithm related information. So this is e to the x. A reminder that e is 2.718281828. Yeah, you get the message. So this is like pi, only they decided to take one of our familiar letters to let it be a number rather than pi, which is a Greek letter. So this time I was able to write down the derivative information in words. So if you've got y is equal to e to the something or other, then y prime dy by dx, f prime at x, depending on what you're looking at, is equal to repeat the exact same thing and then multiply by the derivative of the exponent. Maybe this lets you in on some math memes, because there are some about e. All right, let's try some of this stuff. So we've got 5 questions here, 3 more here, a couple that include ln and trig. I will do this one even though I am very aware that we have not done trig yet, but you can come back and maybe understand it more fully later. And then these questions, or I guess this question, no, these 2 questions to follow. So a little bit longer than ln x, or y equals ln x. So dy by dx. Derivative of e is repeat, then multiply by the derivative of the exponent, which is 3, and then your job is to make it look pretty. The end. I really like this compared to ln's. Next one. Derivative of e is itself, including its exponent, times by the derivative of the exponent, and then you keep going. So the derivative of this is 0. So maybe you don't even want to write that down, and then you get this answer. Now with this one, I want to give you an alternate answer, because there is an alternate answer. Sorry about your luck. You are in calculus, and of course those are locked in. So my or answer this time is you could have this, because this exponent is negative, which shoves it down into the basement and makes it positive if you rearrange. So just a little FYI. Next question. The derivative of e is itself multiplied by the derivative of the exponent, and this is meaningless, but you do have to write it down again, and then to make it look pretty, you do this. So this does not have an x attached, which means you can actually just leave it there. And my favorite question is this one. Derivative of e is itself multiplied by the derivative of the exponent. That's the meme, in case you ever run into it. All right, this should not be the favorite. This is going to take the quotient rule. So I'm going to need some space, and I'm going to do this all textbooky, meaning I'm not going to dig out my green pen and break this down. So if you need to, do that or ask me for help. Derivative of the numerator. Itself multiplied by the derivative of the exponent multiplied by the denominator, because this is the quotient rule. Minus for quotient rule. Derivative of the denominator. 1 gives us 0, thankfully. Derivative of e to the 2x is e to the 2x times the derivative of the exponent multiplied by the numerator over the denominator squared. Do not cross those out. There isn't one back here. That's illegal. So now I'm going to make it look nicer. So I'm basically going to take this information here and multiply it into this bracket, so I don't have any brackets left. Back here, it's all a big monomial, so I'm going to leave it. So 2e to the 2x times 1 is 2e to the 2x. 2e to the 2x times e to the 2x is positive 2e to the 2x times e to the 2x. Now you could make that 4x because you've got same base, add the exponents, but I'm going to leave it temporarily because I see something coming. Minus sign, I have to do all of this multiplied together, so I'm going to put the 2 down first, then this e to the 2x, then this one. Not that you could tell. And again, that could be e to the 4x. All of that over the same denominator. Do you notice what I noticed? This and this will cancel each other out. They are identical. One's a plus, one's a minus. So I actually have 0 of them, which means my overall answer for dy by dx isn't all that bad after all. And here is where I stop. I don't think I need to remind you not to do extra math and not actually multiply out this denominator. Stop. All right, some more stuff. So I'm going to leave f to the end because maybe you don't want to get freaked out by it. And let's look at g. Don't know how much room I need, so I'm going to pull it here. So, oh crap, derivative of ln. Derivative of ln, 1 over what you're lawning. Terrible math speak. Multiplied by the derivative of this, which is 0. And then I have to take the derivative of e to the 2x, which is itself, times the derivative of the exponent. Hey, that's not so bad after all. All this stuff is on the numerator. Then we have the denominator. Do not cross out these two things. You cannot do that. Maybe that would help. H requires the product rule. Do you see why? And I'm going to flip back in a second. We've got two pieces here. And in case you're thinking, well, why didn't I do it here? It's because if I split this here, the front part doesn't have any x's, so I'm not going to really have to worry about that. So that was the benefit of question C over question H. So this, unfortunately, requires us to do the product rule. And I can't use y prime this time. I'll use f prime at x equals. Derivative of the front, easy enough, times repeat the back. Plus for product rule. Derivative of the back, itself. Derivative of the exponent, front, over nothing, because that's for the quotient rule. Sorry. That's for the quotient rule. All right, so now I'm going to make it look pretty. Oh, my front half is very pretty. My back half, not so much. So 4x to the 5, 3 here, 2 here, and then that e business. And I'm going to factor just for the practice of it all. So I can take out a 2x e to the x to the 4. From here and here. And I don't know why I put down a square bracket when a round one would have done just fine. So I took all of it out. Need a placeholder 1 plus. I took the e out, so I'm going to think about that first because it's awful and I'm excited that I don't have to write it down. 2 times 2 is 4. Excuse me. And then I took 1x out of 5 x's, so I'm left with 4 more. And that is the most factored version of f prime at x. So now back to the trig that you possibly know nothing about at this point. This is, again, not going to take the product rule because my front part doesn't have any x's. So at least there's that. So dy by dx, y prime, your preference, equal to, keep the 2 written down. Derivative of e is itself, and then the derivative of sine x. Derivative of sine x is cos x. Then you have to take the derivative of this, which is 1. So our end answer, for those of you who have done some trig, depending on your order, probably dictated by me, but sorry about that, is this. All right, so back to non-trig. We've got these two questions. So I'm going to pull this down. I have no idea how much space I need. I can keep pulling it down. I can even, probably a better idea. Let's just make a new sheet. And determine the equation of the tangent. So tangent means I have to take the derivative. Equation means I need y equals mx plus b. I have x, so I'm about to do the slope of the tangent, which is the derivative. And unfortunately, this will require the product rule. Derivative of the front times the back, plus for product rule. Derivative of the back, not much there. Don't forget to times it by 10, and then don't forget to times it by the front. So I'm going to make that look a little bit nicer. And if you want to factor, you go right ahead. I don't need to factor. I need to put x equals 1 in there. So it doesn't matter if you factor this question or not. You should still get the same slope of the tangent. So e to the 10 times 1 plus 10 times 1 times e to the 10 times 1. So that's e to the 10 plus 10 e to the 10. And there is an invisible 1 sitting right there. So the slope of the tangent is equal to 11 e to the 10. I don't need to worry about the slope of the normal. That makes me excited. So I can almost start my y equals mx plus b. I've got an m. It's super ugly. Oh well. I've got an x. I just need a y. So remember how to find your y, and that is to stuff the x into the y. This gives you y prime, not the same thing. So y equals 1 e to the 10 times 1, which is e to the 10. So your lines aren't always as pretty as they were in the past. So input, e to the 10 is the y, 11 e to the 10 is the m, 1 is the x, b is the unknown. E to the 10 equals 11 times 1, e to the 10. E to the 10 minus the 11 e to the 10 from the other side equals b. I'm going to put a 1 there so I have some easy math to take care of. And that will mean that b is negative 10 e to the 10. And we can't stop. And the reason we can't stop is the question asked us for the equation of the tangent. So stopping there doesn't help us entirely. So therefore, the equation of the tangent, which is actually a tangent line, because there's no other type of tangent, is y equals m x plus b. And don't try to add any of this stuff together. One of them's got an x, one of them doesn't. Like terms don't apply here. All right, last question. Ooh, it's a prove question. So it says if y is equal to e to the 2x then minus 1 over e to the 2x then plus 1, prove that the derivative is equal to 1 plus y squared. So I guess the first thing I should do is take the derivative. I mean, who's kidding who? We have to do that anyhow. Remember that this is going to take the quotient rule. So, blue pen, dy by dx, just because it's used over here on the right. Derivative of the top. There's the e part, the 1 won't matter, times the bottom. Minus for quotient rule. Derivative of the bottom, here's the e part. The 1 doesn't count because it's a 0, times the top over the bottom squared. Do I need to remind you that you cannot cross these out? All right, so the next thing I'm going to do, I'm going to take this and multiply it in here, and I'm going to take this, which is included with the negative, and multiply it in here. Leave the bottom alone. So 2e to the 2x times e to the 2x. Hey, we've done this kind of thing before. If you want to make it 4x, knock yourself out. 2e to the 2x times 1. Negative 2e to the 2x times e to the 2x. And negative 2e to the 2x times negative 1. All of that over the same denominator. All right. Hey, this and this cancel out, just like that other question. Don't expect it to always happen, but sometimes it does. I can collect like terms. I can collect this one and this one. They are not the same and opposite. They are the same. So my dy by dx is equal to 4e to the 2x over e to the 2x plus 1 squared. So you get a lot of marks for doing that. But that was not the object of the game. The object of the game is to prove that this is the same thing as 1 minus y squared. So I'm going to change colors and figure out what 1 minus y squared is. So that's 1 minus e to the 2x minus 1 over e to the 2x plus 1 times itself. Now I see some foiling potential here, so that's why I'm writing it like this instead of with the squared. Now, you do have to be aware of things where you can cut down on your work. For instance, not what I intended to do. For instance, I am going to leave this as e to the 2x plus 1 squared, because that's what's sitting here. Now, that can be multiplied out eventually, but I don't need to right now. Let's focus on multiplying out the top. So I've got e to the 2x times e to the 2x, e to the 2x times negative 1, e to the 2x times negative 1, negative 1 times negative 1. Whew, that's messy. Just because of how much writing I have to do, I am going to do that, and I'm going to say I've got 2 of these plus 1, all of that over e to the 2x plus 1 squared. All right, do you see the unfortunate business here? This, which is what we're aiming for, is 1 fraction, and this is 2. So I should do my little 1, 2, 3 deal, which is why I put down the 1. I'm going to have to not do it in red, so I have to multiply these two things together. Still happy with that. I'm going to take these two things and times them together. Now, because I've got no brackets over here in blue in my numerator, this is where, unfortunately, probably beneficial for me to eventually multiply that out. And then minus all of this, which actually means minus this plus the next one minus the one after that. So I'm actually having to take this negative and run it through. All right, time for more foiling. E to the 2x times e to the 2x is e to the 2x, e to the 2x, or e to the 4x. Whew, e to the 2x times 1. 1 times e to the 2x. 1 times 1. Blah, blah, blah. Over, I'm not going to FOIL that out. It's exactly the same as what's in blue. And the thing is, I'm supposed to take all this red stuff and hopefully have it be the same as the blue. So why would I multiply that out? I mean, I did, but I didn't have to in 2 places. So collect like terms and hope for the best. E to the 4x. Ooh, minus e to the 4x. They cancel. 1. Minus 1. They cancel. 1 e to the 2x plus 1 more e to the 2x plus 2 e to the 2x is actually 4 e to the 2x, still over the exact same denominator. And, big screen, drum roll. Oh my gosh, they're the same. Okay, you can't see it very well. Smaller screen. There's the blue. Oh, it's together. There's the red. They match. They were supposed to match. So, what I can do now that it all worked out, and remember what I told you in advanced functions, when I say prove, it's going to work out. It's just a matter of you not making any typos. Now that we've got that, I can write a little therefore statement. It's not exactly left side equals right side, but I can write therefore dy by dx is equal to 1 minus y squared. Because it worked out. Ta-da! All right, so on the Google site, there are some sheets attached. I believe this one, the e to the x derivative lesson, has a sheet B attached. 1, 2, 4, 5, all of that, 3, A, B, D. So the stuff in the textbook, not fantastic. Anyhow, that is it for this, and not it for logarithms. So there is still logarithmic differentiation, and there's still, sorry about your luck, applications. Remember, I did not make this stuff up.